One of the key concepts that we need to go over with regard to project management is the concept of critical path and how it relates to slack. And what we're going to do here is we're going to go through a couple of PowerPoint slides and break this down for you step by step. Now, the technique we've been using in Microsoft Project is referred to as the critical path method, and we've been using something referred to as an activity on node network diagram. What we see here is a representation of the activity on arrow network diagram representation, and very simply the only difference is that instead of using nodes to represent activity A, B, C, D, E, etc., what we're using is arrows. And in this case, the arrow for activity B starts on day 0 and extends 4 days. Then after activity B would be activity E starting on day 4, ending on day 9, followed by activity I, going to day 15, and then a one-day activity K. Now, these 4 activities represent a 16-day critical path for our project. And again, this is the activity on arrow representation, not the activity on node that we're familiar with Microsoft Project. Now, in this diagram, the dashed arrows represent slack on the tasks that are not on the critical path. And one of the ways we define critical path is it is the activities in a network that have the minimum amount of slack. In this case, it's 0. We use the word minimum because if our project gets behind, then technically we could have negative slack. But let's just stick with the definition that the critical path is defined as the series of tasks that have 0 slack. Okay, so we can see here, again, the dashed lines represent the slack with activity C, A, G, H, and F. Now we break down slack into 2 definitions. We have free slack and we have total slack. And what we see here is the definition of free slack, which shows that it's the amount of time an activity can be delayed at the start of a longer parallel activity. Again, parallel or concurrent activities that can be run at the same time. It's also how long an activity can exceed an early finish date without affecting the early start date of any successor activity, and we're going to demonstrate this in a moment. Now, what we do with free slack is that we're going to use the free slack to adjust our project in POM Part 2, where we have to move some resources around to level. But first we need to understand the difference between free slack and total slack. The easiest way to explain the difference between free and total slack is basically through a demonstration. And we're going to start here by saying, all right, how much can activity C be delayed? And that's your first question. We're going to let you think about that for a second. And again, we're just going to point to activity C. And we see activity C is a 3-day task. And we see a 1, 2, 3, 4-day dashed line indicating potentially up to 4 days of slack. So the question is, how much can activity C be delayed in our project network? So let's take a look at free versus total slack. Activity C has 4 days of free slack because it can be delayed these 4 days, 1, 2, 3, 4, until it bumps into activity C. Now we call that free slack. Right? And again, these were our original 4 days. If we go back to this diagram, we see there's the 4 days, and what we've done is we push C all the way to bumps into G, and that defines what we would consider free slack. Now moving along, we have to explain what total slack is. And if we take a look at that, we say that activity C has really 7 days of total slack, which includes its 4 days of free slack, plus these 3 days of slack that are on the path of A, C, and G. So if we take a look at total slack, we can push all that slack activity back here prior to starting C. And what we've done is we have basically we've stolen the slack from activity G, and we have called that 7 days of total slack. Continuing the concept, the question now becomes, how much can activity A be delayed? and we're going to call that total slack because activity A has 7 days of total slack along the path. It would also be called 7 days of free slack. So sometimes you see, when you look at project, you'll see the free slack and the total slack columns agreeing with each other, and there you can see a demonstration of the reason. Now, one quick question: how many critical paths are there in this project network? And the answer is there are 2. One critical path remains B, E, I, and K. In other words, there's no slack along that path. However, we now have a new critical path with B, D, C, and G. So what we're learning here is that if we take slack and we redistribute it, we move it, we steal it between tasks, we can actually get ourselves into a situation where we have multiple critical paths, and when we have multiple critical paths, we increase the complexity of our management. So that's why we want to take a good look at what critical path there is, and we want to be careful how we use our slack, but recognize we can use our slack to move tasks around if we have resource problems. All right, one quick review. We're going to take a look at if we delay activity F, how much can we do that? And the answer would be just this 1 day. We can push F to start here instead of day 4, day 5. That would take the start of H from the start of day 6 to 7, and that's as far as we can push F. So what's the impact on J? Basically what we're going to do is we're going to take 1, 2, 3, 4, 5. We're looking at 6 days of slack with activity J, and we're going to steal 1. So if we wait getting activity F started, we now put H on the critical path, and what we do is we take 1 day of slack off of J. So again, this is just, and that, by the way, this 1 day of slack for activity F, that would be 1 day of total slack, and we would consider activity F having 0 days of free slack. So that's a real quick review of critical path concept, free slack, and total slack using an activity on arrow diagram as opposed to the activity on node representation, which is what Microsoft Project uses.